Okay, class, we're going to dive into complex numbers, and you kind of wonder, why does this have any relevance in the current topic that we're on, which is, solutions to polynomials and so on and so forth. Well, if you consider something like y is equal to x squared plus 1, the fact is that when you see the 2, you would say, well, it's going to have two solutions. And yet when we graph it, we can see that it does not cross the x-axis. So mathematicians for many years, they kind of disregarded this as having solutions, but once they said, well, we're going to make it so it does have a solution. In order to have solutions, it's going to have to involve these complex numbers or the imaginary number system. I'll try to explain to you a little bit more about the difference between imaginary and complex. But once they decided that this has solutions of plus or minus I, the fact is that mathematics didn't really, mathematics flourished, but they did wonder what kind of good would ever come from something like this. As we've said before, without the imaginary number system, we would only have direct current electricity and not alternating current. Alternating current is what is in your homes, and direct current is what is in your car. And so if you only had direct current electricity, we would have to have a power station on every block of Albert Lee in order to power things. But through the complex numbers and imaginary numbers, we end up being able to work with alternating current, which means we have one power station within the town. So a big difference there. It definitely did change things for the better. So sometimes things come up in math that we don't necessarily understand. And so it's actually, don't think of this as the XY plane. Think of this as the real number line that you plot things on. Like 0 is right here, and -5 is over here, and +5 over here. And then this is the imaginary number line. And so you have real number line, you have imaginary number line. We say that the square root of -1 is I, and then I squared is -1. So, -1 is located here, but I, we would say, is 1I would be located there. And so we call this the complex plane. And we're going to get more into that in second semester, but this is called the complex plane. And it really did revolutionize mathematics. What we like to do is we like to combine these two ideas, imaginary and real. And we say that every complex number has two parts, a plus bi. This is the real part, and then this is the imaginary part. And when we consider that type of number, we do understand then that this type of equation has solutions. So when it says perform the indicated operations, we always want to make sure we write it in terms of a plus bi. The nice thing about complex numbers, you can add the real parts and subtract them. So 4 minus 6 is -2, and then 3i minus -8i is 11i. So I always write it as a plus bi. For the next one, I'm going to write as 1 minus I plus 3 minus I minus 6 plus 5i. As you see, you have 1 and 3 is 4. Minus 6 is -2. Negative I and negative I is -2i plus 5i is positive 3i. Again, I write it in the form of a plus bi. You can multiply them together. So 4i times 7i is 28i squared. And from what we have said right here, I squared is -1. So this becomes -28. In this case, we have -24I squared. Because I squared is -1, this becomes positive 24. -2i times -I would be positive 2i squared. And because I squared is -1, this result is -2. 6i times -I times -2i. 6 times -1 times -2 is positive 12. And it's I cubed. Or in other words, 12 times I squared times I. We know that I squared is -1, so it'd be a -12I. It's always nice if you can write it with a squared. So -I squared times I. Notice that I squared is -1. The negative will make positive 1, so this resolves to just I. So what do we do about something like I to the 122nd power? Would seem like it would take a long time to kind of work through things, but this is the same thing as I squared raised to the 61st power. Well, I squared is -1. If you take -1 to an odd power, hopefully you understand that you would get -1. And so writing it simply as an I squared can really help you resolve uh, the simplifying into the proper form. You can multiply by distributing, so we get 6i minus 15i squared. Since I squared is -1, we have 6i plus 15, but we write it as a plus bi, so 16 or 15 plus 6i. Notice in this situation, these are conjugates, so you know the middle is going to go away. We have 4 plus 2i minus 2i minus I squared. As you saw, the middles will go away, and we have 4 minus I squared. I squared is -1, and so 4 minus -1 is positive 5. Six times 3 is 18. 6 times 7i, 42i. I times 3 is 3i. And I times -7i will be -7i squared. 18, -42i and positive 3i is -39i. And because I squared is -1, this becomes plus 7. So 25 minus 39i. Again, the goal is to always write it in the form of a plus bi. And if you have I in the denominator, then it is not in the form of a plus bi. So what I'm going to do in this situation is I'll multiply the top and bottom by I. And when I do, I get 4i over -1, or -4i. Some people like to multiply top and bottom by 2i. Not necessary, just I will be fine. And I get -3i over, in the bottom you have 2i squared. So I squared is -1, so you have -3 over, or sorry, -3i over -2, or 3/2 I. So again, this is the way we like to write it because it's of the form 0 plus 3/2 I, where a is 0 and b is 3/2. So that's the proper way of writing it. So in this situation, if we multiply top and bottom by I, notice that you end up in the bottom with an I squared plus I. And so your I did not go away. So we're going to use a little trick here. If you remember, when you don't know what to do for math, you just do Spanish. We multiply by the conjugate. Remember in that example up there that the middles went away. So I minus 1 over I minus 1. So in the top, 3i minus 3. And in the bottom, I squared minus I plus I minus 1. Notice how the minus I and the plus I went away. We have 3i minus 3 over I squared is -1 minus 1, or 3i minus 3 over -2. Now this is not written in the form of a plus bi. But the a part would be -3 over -2. And then the b part would be 3i over -2. So minus 3 over 2i. So positive 3 over 2 minus 3 over 2i. That's what we're looking at. That way this is A and this is B. Okay. This one we multiply by the conjugate, 5 minus 2i over 5 minus 2i. In the top I have 10. I have minus 4i minus 5i plus 2I squared. And in the bottom, 25. Hopefully you see that the middles are going to cancel. So I'm going to have positive 2I times negative 2I is a negative 4I squared. Let's deal with our I squared. So we have 10 minus 9I, and then the I squared would be a negative 1, so this will result in negative 2. In the bottom, 25, this I squared will be a negative 1, so it'll be a positive 4, so plus 4. So notice we get a 8 minus 9I over 29. So as we write that in the form of a plus bi, it would be 8 over 29 minus 9 over 29i. One last thing I want to show you. This was kind of different for me. I didn't fully understand it. But if you were to take, say, square root of negative 3 times, say, the square root of negative 12. So I often would work through this problem when I first saw it, and I would say, well, negative 3 times negative 12 is positive 36, and the square root of 36 is, in fact, 6. But turns out that's not the way you do the problem, and I was wrong for thinking that. I just did what I thought was right. And it comes back to this idea that if we say the square root of 25, we don't list both positive 5 and negative 5. We say it's 5. We call that what is the principal root. It is true that negative 5 times negative 5 is 25. But if we are doing an operation like the square root, we say it produces one value, which is 5. And when we have the square root of negative 25, we say that the principal root is 5i. And if we take that a step further, the square root of negative 26, we would say is I roots of 26. So we first must list the principal root. In this case, the principal root is I roots of 3 times, and in this case, we would have the root of negative 4 root of 3. So I roots of 3 times 2I roots of 3. Now watch what happens when you multiply them together. You get 2I squared roots or times 3. And I squared is negative 1, so you can see you get a negative 6 result. So this expression here does not result in positive 6, it results in negative 6. You first extract the I, showing the principal root, and then working it through. So anyway, there's a nice introduction into imaginary numbers, complex numbers. These are going to be important because, like we said, you can draw a cubic so that it crosses 3 times, has 3 solutions. You can also draw a cubic so it only crosses once, and that means it has 2 complex solutions. And so we have to have an understanding of complex numbers before we finish off our kind of approach to polynomials. Good luck. Hope to see you guys soon.